Hello, hello, testing. Okay. Hello. Hi. Can you confirm whether I'm audible? Thank you. I think we'll start in like some 2 to 3 minutes. Hi. So maybe we can start. I think around 12 people are there. So shall we start?
Yes, sir.
Okay. Thanks. So good evening. My name is Prashok. So I'm doing PhD in ISC Bangalore. So every Wednesday during this time 7 to 8 we'll be discussing key questions on signals and systems communications and some max topics. So today we'll be discussing mainly on linear algebra, and in that we'll be discussing some questions on system of linear equations, the nature of solution of the system of linear equations, and some more related topics. So we won't be having much of theory here, so it will be more problems than theory, and we have already had one session some time back. So as and when required, we will be review the theory needed for that particular question, and then we will be solving. So we can start with discussing some problems related to the system of linear equations. So a system of linear equations is like this. So we have equations of the form a11x1 plus a12x2 plus etc. plus a1 and xn equal to b1. This entire thing is like one one equation. Then we have a21x1 plus a22x2 plus etc. plus a2 and xn equal to b2. This is second equation. Like that, we have m equations. We have am1x1 plus am2x2 plus etc. plus amn xn equal to bm. So we have a collection of m equations, and here a11, a12, a1n, a21, etc. These are known quantities. These are known quantities, or we can say these are the coefficients. And b1, b2 up to bm, these are also known quantities. So usually b's are referred to as observations or measurements, something like that. Now this x1, x2 up to xn, these are the quantities which are not known. So this AIs are basically the AIJ, these are the coefficients. XI, these are the unknown, and BI, these are let's say the observations, or let us say it is known quantities. Now, so this entire collection of M equations in n unknowns form what is known as a system of linear equations. Now, this entire system can be compactly represented using this matrix vector notation that we have here. We can write this system as a product of a matrix with a vector to be equal to some other vector. So what we have this a11, a12, sorry, up to a1n, a21, a22 up to a2n, like that. We form a matrix called the A matrix. Then we collect the unknowns x1, x2 up to xn in this vector that we have here. And similarly, we have this b1, b2 to b1 in this vector. So here, the system of equations can be written compactly like Ax equal to b, where A is known as the coefficient matrix, x is the unknown, and b is the observations or the measurements or something that is known. So our objective is to find x. That's objective. Now, typically, so in this case, for example, we have m equations in n unknowns. That means this A matrix will be having dimension A will be having the dimension m cross n, x will be having the dimension n cross 1, and b will be having the dimension m cross 1. So what we will now see is how these solutions will be there. So the setup is clear, right? Any doubts? Shall we proceed? If I'm going too fast, or if there is any doubt at any point of time, please feel free to interrupt. Okay, I think we can proceed. So now what we have? So we have this A matrix. This is having m rows and n columns, and so these are the different nature of solutions that we can have. So this system Ax equal to b, this system is said to be consistent if there exists at least one solution x. When I say solution, what it means is that it is possible to find a set of values of x so that Ax equal to b. That is the meaning of finding a solution. So the system of equations is said to be consistent if there is at least one solution x. Now, what is the condition for the solution to be existing? Basically, we want to express this vector b as a linear combination of the columns of A. That is the meaning. Or basically, when we do Ax, we are taking the first column of A multiplying with the first entry in x1, then adding the second column of A multiplied by the second entry in x, and so on. So basically, if we say that there is a solution, that means this vector B should be expressible as a linear combination of the columns of A. That's the idea. Now, how do we check for that? So that statement is pretty standard, but how do we check for that? So the condition to check whether a given system of equations is consistent or not, or whether there exists a solution or not, is this condition that we have here. So at least one solution. That solution exists when rank of A is same as the rank of this augmented matrix A augmented with B. So this case basically we have a big matrix A. We stack the column after that. So this will be having dimension m cross n plus 1. This will be the augmented matrix. So if the rank of A happen to be same as the rank of this augmented matrix, then the given system of equations is said to be consistent and there exists at least one solution. Now, how many solutions we have? That depends on these things. If the system is consistent and if rank of A is same as the number of columns of this matrix A, in that case, we have a unique solution. Next is that if rank of A is same as this thing, but it is less than it, that means the system is consistent, but the rank of A is less than the number of columns of A. In that case, we have infinitely many solutions. Finally, if rank of A is not same as the augmented matrix, then there is no solution. So only these three possibilities are there. Like you will never have any case where you have exactly two solutions, exactly three solutions, not like that. Either we have one solution, or we have infinitely many solutions, or we don't have any solution at all. These are the only three possibilities that are there. So these are the backgrounds required regarding system of linear equations. So any doubts till now? If everything's okay, we can proceed further. So I think okay. Shall we proceed further? If something is not clear, or if there's any clarification, please let me know. Shall we continue?
Sir, what is n?
The number of columns of A basically. So A is M cross N. So A is this M cross N, and N is the number of columns of this given matrix A. Okay.
Okay.
Shall we continue? Any other questions? Can continue now. Once again.
So can continue.
Thanks. Okay. So this is the first question that we have. So this question is like this: we are given with a system of linear equations. So and we are asked to comment on the nature of the solutions to the system. So question is like this: this equation that we have here, 2 minus 2 1 minus 1 x1 x2 equal to 0 0. What is the nature? Do we have no solution? Do we have only one solution, which is happen to be 0 0, or do we have one solution but it is not 0, or are there multiple solutions? So this is the question. So so in this question, so if we recollect from here, these are the different cases. Like if rank of A is same as rank of A augmented B, then there exists a solution, and depending on whether or not this rank is same as the number of columns or less than the number of columns, we can say there is one solution or multiple solutions. And if this is not true, then we don't have any solution. That's the idea. So if you see here, what do we have is, so the question is clear, no? Basically, we are given with a system of equations, and we are asked to comment on the nature of solution to this system. So we have A to be 2 minus 2 1 minus 1, and this vector B happens to be 0 0. Now what do we want to find? We want to find what is rank of A and what is rank of this augmented matrix A augmented with B. So before doing that, we will define what is rank. So rank of A, what is rank? This is defined as the number of linearly independent columns in a matrix A. Basically, the maximum number of linear independent columns in this matrix, and that happens to be same as the number of linear independent rows of this matrix. That's a different thing. So basically, we need to find what are the maximum number of linearly independent columns in this matrix, or rows, whichever is easier. So number of linear independence. Okay, so if we see here, what do we have? A matrix is given like this. So what do we have is like 2 minus 2 1 minus 1. Now if you see here, it is easy to find the rank of this given example, because if you see this first row and second row, they are basically scaled versions of each other. Or if you say first column and second column, they are again scaled versions. So what we can say is that row 2 is a scaled version of row 1, or I can say that R2 is basically R1 half times R1. That is the relation between these two rows. Any questions? Okay. So what it means is that rows 1 and 2 are linearly dependent. So what it means is that rank of A is 1. So is this okay? This is fine. So we have a 2 cross 2 matrix, and it so happened that the second row is a scaled version of the first row. So that means the rank of this matrix is 1. Is it okay? I think somebody typed the solution. That's actually correct. Many solutions is the answer. So we'll see. This is fine, no? So we found out what is the rank of A. Now what is rank of A augmented B? So this A augmented B, this is given like this. We have 2 minus 2, 0, 1 minus 1, 0. Once again, if you see, we are adding only zeros, right? So it doesn't change any of the other terms. So this, sorry. So this second row is still a scaled version of the first row. That means this is also having rank 1. So rank of A augmented B, this is also 1. So what do we have? We have rank of A same as rank of A augmented B, which is 1 but less than 2. So this means it falls into this category, what we have here. We have rank of A to be same as the rank of A augmented B, but which is less than n. That means there are infinitely many solutions, or basically multiple solutions. So the correct answer is option D. So is there any doubt, any clarifications? If it's okay, we can go to the next question. Am I going too fast? Like, please let me know if something is not clear. Shall we continue?
Yes, sir.
Okay, thanks. Okay, so next question is like this. This is slightly, yeah, I mean, we don't have the matrix, but we have the equation itself. So, given a system of equations, x plus 2y plus 2z equal to b1, and 5x plus y plus 3z equal to b2. I'm sorry. Which of the following is true regarding its solution? So, A is that the system has a unique solution for any b1 and b2, or the system will have infinitely many solutions for any given b1 and b2, or then whether or not a solution exists depends on b1 and b2, and finally the system don't have any solution for any values of b1 and b2. So these are the four options. So given the system of equations, we need to find which of these options is the correct answer. So how do we do that? So again, like this is just a recap. Like we have ax equal to b. If this is true, we say solution is there and consistent. And if rank of A is same as rank of A augmented B is same as number of columns of A, then we have unique solution. Whereas if rank of A is same as rank of A augmented B but less than, then we have infinitely many solutions. And if these ranks are not same, then we don't have any solution. This is the just a restatement. I mean, we are just revising what we already discussed in the beginning. So what do we have here? So in this case, if we see here, we have two equations, three unknowns. So to see the nature of the solution to the system of equations, we can write this in the usual matrix vector form. So we have A given by this 1, 2, 2 and 5, 1, 3. So this is a 2 cross 3 matrix. And it is, we need to find what is the rank of A. So it is easy to see that rank of A is 2. Why is it easy? Because the two rows, I mean the row 2 and row 1, these are not scaled versions of each other. So row 2 and row 1 are not scaled versions of each other, which implies that R1 and R2 are linearly independent. That is the meaning. So the rank of this matrix A is 2. Now, I'm sorry. Yeah. What do we want? We need to find what is the rank of this augmented matrix. And this augmented matrix is like this. We have the same A matrix 1, 2, 2, 5, 1, 3. And we add this B1, B2 as the last column. Now, this is a 2 cross 4 matrix, whereas this was 2 cross 3 matrix. So we have a result. It's like this. So whenever we have a matrix that is kind of not square matrix, the maximum rank of that matrix, an m cross n matrix, is the smallest value among m and n. So what it means is that if a matrix is 2 cross 3, the maximum rank is 2. And if the matrix is 2 cross 4, the maximum rank is 2, still 2. Because 4 is larger than 2, and we can have only the maximum number of linear independent columns or rows, one of this. So whichever dimension is the smallest, that is the maximum rank that is possible. So this statement is clear. No, I mean, this is the main thing regarding maximum rank of an m cross n matrix is the min of m comma n. So this statement is fine. No, can continue, right? Okay. So now what do we have here? So here for this A matrix, we already seen that the rank is 2. Now we are only adding one extra column. We are not touching the entries that are already there. That means this row 1 and row 2, these rows are still linearly independent. So basically by adding a column, we cannot reduce the rank. Basically, we can't kind of make these two things linearly independent. I mean dependent. That is not possible. Similarly, the maximum rank of this augmented matrix, this is 2. Why is that so? Because this 2 cross 4 matrix and the maximum possible rank is 2. But we already know that this is always having rank 2 because this much part, if you see this much part, the A matrix, that is already having rank of 2. So if we add like few more terms here, the rank will not reduce and rank also cannot increase because 2 is the maximum value possible. So what it means is that irrespective of the values of B1 and B2, rank of A is always same as rank of A augmented B, which is same as 2. So this is nothing but which is same as we can say n. So what it means is, so this is the thing. So irrespective of the values of B1 and B2, the rank of A is same as rank of A augmented B, which is equal to 2. So what it means, the given system of equations is consistent. Okay, so this is not 10 actually, but yeah, this is just 2. That's it. Moreover, rank of A is less than n, which happens to be 3. So n is the number of unknowns we have. We have x, y, and z. So n equal to 3, m equal to 2. So what do we have? We have rank of A same as rank of A augmented B, which is 2, which is less than n. That means again this falls into the previous case, like there are infinitely many solutions. The point to note here is that the rank of A augmented B is always 2, irrespective of the values of B1 and B2. So irrespective of what are these B1 and B2, the rank of this augmented matrix is always 2. That means no matter what the value of B1 and B2, this given system of equations will always have infinitely many solutions. That statement is fine, no? If something is not clear or if I'm going a bit too fast, like please let me know. And if I'm not audible also, please let me know. So what do we have? What it is saying is that this given system of equation will have infinitely many solutions for any B1 and B2. It doesn't really matter. So where is it? Yeah. Option B is the correct answer. The system will have infinitely many solutions for any value of B1 and B2. That is the solution. So any doubts so far? Shall we proceed further? Okay, thanks. So yeah, this question is a recent question. It's appeared in instrumentation exam basically. So these are math topics. So this can, it's not necessarily come in EC itself. It can be in any other gate paper also. But like since this is math, this is kind of common for many of the papers. So it's good to try from other papers also. so so what do we have? So this is the question. So a set of linear equations is given in the form ax equal to b, where A is a 2 cross 4 matrix with the real number entries and this B is not 0. So the question is, will it be possible to solve for X and obtain a unique solution by multiplying both left and right sides of the equation by A transpose and then inverting the matrix A transpose A? That's the question. So is the question clear? So what it says is that we have a system of equations ax equal to b, and a is like 2 cross 4. So naturally x will be 4 cross 1 and b will be 2 cross 1. So the question is that is it possible to get a unique solution? So by multiplying both left and right sides of the equation by A transpose and then inverting the matrix A transpose A. So is the question clear? And the options are like this, like yes, it is always possible to get a unique solution for any matrix. Then no, it is not possible for any matrix. Yes, we can obtain when this is well conditioned, and of course we can obtain when this matrix A is well conditioned. So which of this is the correct answer? That's the question. So, and we don't have any actual equation. I mean, we don't know what are the entries of this matrix of matrix A, or we don't know what are the values of B. The only thing we know is that A is a 2 cross 4 matrix and B is not 0. So that much we know. So given this fact, can we really find a unique solution? That's the question. So is it, the question is clear? So there are two ways to solve this question. This is a simple question actually. So what do you want is that to get, I mean, yeah, for unique solution we need rank of A to be same as rank of A augmented with B to be same as n. That is the condition that we need. So what we have, so this means rank of A should be same as n, which is 4, should be same as rank of A augmented with B. So now what is A? A is 2 cross 4. So maximum rank of A is 2. Why is that so? Because just now we have discussed, so if the matrix is like m cross n, like the same thing. If the matrix is m cross n, the maximum rank is min of m comma n. So, sorry, for unique solution, the general condition for unique solution is that we need to have rank of A to be same as rank of A augmented B to be same as n. So here we need rank of A to be equal to 4, which is basically the number of columns of A. But since it's a 2 cross 4 matrix, we cannot have rank to be 4. So that way we can already tell that it is not possible. System doesn't have a unique solution. That is one way. Now, one more thing is that they also mentioned a way of obtaining a solution. Like, can we multiply both left and right by A transpose and then invert in this matrix A transpose A? So what they're saying is that, by the way, am I going too fast, or if something is not clear, like please let me know. So what do we have? So we have Ax equal to B, A transpose A x equal to B. So they're asking like, is it possible? I mean, like, this is what they're asking. So we have A transpose A. Can I just find the inverse of this A transpose to take it to other side and get this B? That's the question. Now, the main thing here is that A is 2 cross 4, right? So rank of A is at the max 2. We don't know. It will not be more than 2. There is one more result that says rank of A is same as rank of A transpose A, which is same as rank of A transpose. So this is a result that is good to know, but I mean we won't be proving it here, but this is a known result. So what it means here, rank of A transpose A, which is basically what we want to find here, right? A transpose A this is less than equal to 2. But say is 4 cross 4 matrix. Therefore, A transpose A is singular, and that means not invertible. So since this rank of A transpose A at the max is 2, this A transpose A is always singular. That means we cannot invert this matrix. So this thing we cannot do. So we can't find the unique solution in this way. So either way, the answer is option B. That is no, it is not possible to get a unique solution for any 2 cross 4 matrix A. That's the idea. So any questions? Is there something that is not clear? Shall we proceed further? Sorry. Okay, thanks. So okay, this is similar to what we did, so we'll do at the end. Okay. This is the question. So two matrices A and B are given below. We have A like PQRS and B like P square plus Q square, PR plus QS, PR plus QS, and R square plus S square. Now, so by the way, this is not related to a system of linear equations. This is but linear algebra, the normal linear algebra, not necessarily the system of linear equations. Now, the question is like this: if the rank of this matrix A is n, then what is the rank of this matrix B? That's the question. So, in general, if we are given with two matrices, it is not possible to find the rank of another matrix in terms of some other matrix. So, that in general, it is not possible. But this result is something that is interesting. So, let us write it once again. So, what we have is that for any matrix, this is a general result for any matrix. We have rank of A, rank of A will be same as rank of A transpose A, which will be same as rank of A transpose. So that is the question that we have here. So how do we solve this question? So any suggestions? Okay, option C is the correct answer. So how do we solve it? Let's see. So what we can do is, so in this case, A is given like PQRS, PQRS. What is A transpose? So this is like PQRS times PQRS, which happens to be like P square plus. This is not what we want. Hey, what am I doing? This should be transpose. Okay. Have P square plus Q square. Now then I have PR plus QS. Then I have RP PR plus QS and R square plus S square. So this happened to be equal to P. So what I did is like since they are given this matrix B here, sorry, something like this. What we can see is we can write this B as A transpose. So we have B equal to A transpose. So furthermore, we also know that rank of A is same as rank of A transpose A, which is also same as rank of A transpose. So what that means is that rank of B is same as rank of A transpose, which is rank of A, which is equal to n, because it is given in the question that the rank of this matrix A is n. So since the rank of this matrix A is n, the rank of this matrix B is again n. So option C is the correct answer. So any doubts here? So these questions, as you can see, these are simple questions. I mean, these won't take too much time. So we can solve these questions very fast in the actual exam also. So yeah. So any doubts or any clarifications here? Shall we move to the next one? So is there any doubt or clarifications? Can we proceed? Okay, thanks. So okay, yeah. This is the next question. We have this matrix A, which is like 1 tan x minus tan x 1. What is the determinant of A transpose A inverse? This is a question. So, how do we solve this question? I mean, there are different ways to solve this. So, the straightforward way is to actually find what are these things, like what is A transpose, what is A inverse. Again, 2 cross 2 matrix, so it is not very hard. And then just multiply them, find the determinant. So, how do we do that? This is so we have A equal to 1 tan x minus tan x 1 like this. So A transpose will be 1 tan x and minus tan x 1. So determinant of A transpose is 1 plus tan square x. And what is inverse of A inverse? This is 1 by determinant of A times. Okay, what do I want? I want determinant of A inverse. So, yeah. So I want det of A inverse. So sorry, det of A. This is 1 plus tan square x. Now A inverse is 1 by determinant of A adjoint of thing but 1 by 1 plus tan square x. Adjoint means like yeah, replace the entries with its cofactors. So 1 1. Please let me know if I make any calculation mistake. So yeah. So this is like this is the adjoint of a one and then yeah. Okay. Now what do we want to find? We want to find A transpose A inverse. So A transpose is like 1 minus tan x 1 and A inverse is in 1 minus tan x 1 times 1 by 1 plus tan square x. So how do we do this? So this is 1. What is it here? Yeah, 1 minus tan square x. So again, like if I make any mistake, please let me know. I might be happening sometimes. So 1 minus tan square x minus tan x minus tan x minus 2 tan x. Then tan x plus tan x is 2 tan x and minus tan square x plus 1. So yeah. Now we need to find what is the determinant. So determinant of A transpose A inverse is basically the determinant of this big quantity. So how do we have this 1 by 1 plus tan square x square will come. and then determinant of whatever we have here. So that will be 1 minus tan square x the whole square plus 4 tan square x. This is 1 minus tan square x the whole square plus 4 tan square x is basically 1 plus tan square x the whole square. So 1 plus tan square x the whole square by 1 plus tan square x, and one of them get cancelled off. And here, did I? No, this is square denominator also, right? Yeah. So 1 plus tan square x the whole square. So these things get cancelled out. The answer is 1. So any doubts here? This is a 2 cross 2 case, so we can easily do this. Now there is a trick or like faster way to solve this question. So what happens is like this. So some properties of determinant. So by the way, like this is nothing complicated. I mean, it looks a bit there, but like I just have this. I just wrote this matrix A and A transpose in full, and I just find out the determinant of A transpose. I found it A transpose. What is A inverse? Multiply to get this for it, and finally compute the determinant. And it turns out to be 1. And it took us around like 2-3 minutes. This is still doable, but there's a much faster way. So some useful results regarding the determinant. So what we have is like this. So first result is that determinant of A is same as determinant of A transpose. That's the first result. Second result, this is kind of interesting and it's strange. So determinant of AB, let's say everything is square. This is same as determinant of A times determinant of B. And there is other nice result that says determinant of A inverse is 1 by determinant of A. So these three results, I think these are already familiar. I mean, we might have seen this during our 12th standard or somewhere during the VTech. So these are the three results regarding determinants. So what we are asked to find, we want to find what is determinant of A transpose A inverse. This is same as determinant of A transpose times determinant of A inverse, because that's separate rule. So this using this first result, this happens if same as determinant of A, and inverse using this result 1 by determinant of A. That means 1 is the answer. So without even doing any of the computation, we can directly say that the answer to this question is 1. So that's another way to solve this question. So any doubts or any clarifications? If it is fine, it's okay. We can move to the next question. Maybe we can do one more question and then kind of wrap up the session. So I think we did like some 4-5 questions already. So maybe one more we can do. So shall we proceed? Any doubts? Okay, thanks. So this is, yeah. Let's see. Okay, so this question is like this: a matrix has eigenvalues -1 and -2. Now the corresponding eigenvectors are 1 minus 1 and 1 minus 2. So what is a matrix? That's a question. So basically they have sorry, they have given the eigenvalues and eigenvectors of some matrix. We don't know what the matrix is. From this information, we need to find what is the matrix. Like, is the matrix this one, or which of these options is basically the answer? So the question is clear, no? We don't know. So usually we will be given the matrix and we will be asked to find what is the eigenvalues and eigenvectors. Whereas in this case, we are given with the eigenvalues and eigenvectors, but we don't know what the matrix is. So using this information that we have here, we need to find what the matrix is. This is the question. So is the question fine? Shall we see the answer? Yeah, I think it's okay. So to solve this question, we use one interesting, important result in linear algebra. algebra known as the eigenvalue decomposition theorem. So it's like this. So what it says is that consider the matrix A with eigenvalues lambda 1, lambda 2 up to lambda n and corresponding eigenvectors v1, v2 up to vn. Then we can write this matrix A as v, yeah, v lambda v inverse, where this v is a matrix with the eigenvalues as the columns v1, v2 up to vn. These are columns, so this is a n cross n matrix. These are basically the eigenvectors, and lambda is a diagonal matrix with the values lambda 1, lambda 2 up to lambda n and zeros everywhere else. So this is the thing. Is everyone clear with this result? Like, this is something that is fundamental in linear algebra. So this is known as the eigenvalue decomposition theorem. We won't be going to the proof of this one, but it's like this. So to summarize, let lambda 1, lambda 2 up to lambda n be the eigenvalues, and v1, v2 up to vn be the corresponding eigenvector. So corresponding basically means we have a vi to be lambda I vi. That is the meaning of saying this lambda 1 has the eigenvector v1, lambda 2 has the eigenvector v2, and lambda n has the eigenvector vn, like that. So if this is true, then what it means is that it is possible to write the matrix A as V lambda V inverse, where V is a n cross n matrix with the ith column being the ith eigenvector. Basically, the first column of this V will be the first eigenvector V1, second column will be the second eigenvector V2, like that, and the nth column is the nth eigenvector Vn. Similarly, this lambda is another diagonal matrix with the eigenvalues lambda 1 to lambda n on the diagonal. So the thing that we need to note is that first entry here is lambda 1, and that match to the this value v1 lambda 1. So first column here is v1, first entry here is lambda 1. Second column here is v2, second entry here is lambda 2, and so on. So this is known as the eigenvalue decomposition theorem. So is this fine? Shall we proceed? Is there any doubt or clarifications? Please let me know. Can we continue?
Yes.
Okay, thanks. So what do we have in this case? Like, it is given that R -1 and -2 eigenvectors are 1 -1 and 1 -2. What is the matrix? So what do we have? We have V to be the eigenvector matrix, that is V1, V2. This is like 1 -1, 1 -2. And what is V inverse? 1 by. So this is like determinant is -2 minus -1, -2 plus 1. So joint of B. So this is minus 1, and adjoint means again like diagonals are swapped, and yeah, and signs are flipped. Okay, did I do it right? Mm, we have minus 2 is 2 1 and minus 1 1. So by the way, let me know if I make any mistake. Like this numerical questions, we should be very careful. We might think something in the mind and write something completely different. So that can happen sometimes. So what is that? So we have minus 2 here, then 1, then minus 1 and 1. I think, yeah, it is be like this only, right? We have to swap the terms and then swap the signs as well. So it will come back to this, I think. So this is like minus 1, 1, minus 1. Okay. Join is right. So this is minus 2 and this term will be 1. This becomes minus 1 but again negative, and this becomes 1 but again negative. Fine, I think it's correct. And then 1 negative comes inside, we'll get this. Fine. Okay. So what is the matrix? We have A given by B lambda B inverse. So what is that? B is given by minus 1 minus 1, 1 minus 2. Lambda is given by minus 1 minus 2, because like for minus 1 it is the eigenvector, and minus 2 it is this eigenvector. So we have this one, and then we have this inverse that happened to be 2 minus 1 1 minus 1. Now 1 1 minus 1 minus 2, what do we have? So this is like the 2 minus 2, sorry, yeah, minus 2 1 and minus 2 2. So what do we have? Minus 2. Did I make any mistake anywhere? Let me know if there is something wrong. I don't think something seems off actually. So what are the options? This is this is not matching with the options that we have. So
Sir,
where did we go
actually,
wrong?
I have
Yeah.
calculated V inverse and I got that as 2, 1, minus 1, minus 1. So, first row should be 2, 1, and second row minus
Okay.
1, minus 1.
I see. Okay. B is like this. This one minus two. So determinant is negative one only, and then how come the
Yeah,
inverse?
it just uh, like, we'll consider that as D minus P minus C A no, sir.
So what is the answer you got? Like, can you tell me once again?
2, 1, minus 1, minus 1. So,
So 2 1 means like a row or column, like
yeah, first row is 2 and 1, second row minus 1, minus 1. Yeah,
Instead of
this is
1,
what I got.
minus 1 should
I
come.
see. Like this. Okay. Okay. Where did we go wrong actually?
Uh,
Hmm. Yeah, some silly mistake, but I'm thinking where did I make that
so,
mistake? So this negative is fine. Also, this minus 2 and 1 get swapped. Then
yeah,
this. Okay. Okay. Think you are right. I think you're definitely right, or at least I am definitely wrong here. So because the answer doesn't match with the option. So yeah, this is some silly mistake somewhere. Like I don't know. So this is correct on 1 minus 1 and 1 minus 2. So we have determined to be -2 +1, so -1 that comes outside, let it be there. Adjoint means like this is there, and signs have to be swapped.
Yeah, D and A, that will interchange, and minus B and minus C we need
Yeah,
to
the
consider on the first one.
signs has to
Yeah,
be swapped. This will be negative and this will be positive. And
yeah.
then that is again one more negative is outside.
Um,
That will come inside and yes, certainly. Yeah.
yeah,
Then it will be like 2, 1, -1, -1. Yeah. Yeah, this is what I was telling. Hey, this can happen. Like it happened with me during exam. So yeah, completely understand. So what do we have? So 2, 1, -1, -1. So what do we have here? We'll be having like so -2 -1 2 2. So now we have, yeah, now it makes sense. This is 0. Then we have -1 plus 2. Okay, 1. And this is -2 minus. No, this is okay now. What is this? -4. So -2 and 1 -4 -3. Yeah, this is there, no? Yeah, this is there. This is there. Yeah, D is there. Yeah, yeah. D is the correct answer. 0, 1 -2 -3. Yeah, this is that. Yeah, this is fine. So yeah, D is the correct answer. Okay. So if I ask if there is any doubt, actually it's me who got wrong in between. So yeah. Okay, so by the way, like before winding up the session, I have one question actually. So next week it's actually the Christmas week and the holiday week, so I'll not be able to take class on next Wednesday. So there will be no class on next Wednesday. I mean, only my class. I don't know about others' classes. My class, there won't be any class on next Wednesday, 7 to 8. So what is it? December 28th. So I have like two options. Like I'll do as per what you suggest. So one option is that we can have this class for on some other day. The class on Wednesday 7 to 8 just for that week. So we can compensate for this class by having a class on some other day. So we can have it on, I think, Monday, Tuesday, Wednesday is like fully booked, I think. So Thursday, is it okay to have a class, or like maybe Thursday, not that week, the week after that. So January 5. Is it possible to have a class on January 5 Thursday? That is one option. Other option is we can just cancel the class. Like that's also fine with me. So whichever you prefer, I will do that. So this is, so either of these days, 6 to 7 or 7 to 8 on January 5 Thursday or January 6 Friday, we can have a class. If that is not possible, then we can cancel the class. Like the other days, Monday, Tuesday, and all, like already there are two classes, so it's not possible to add a third class. And generally, I don't prefer keeping class on weekends. That is not good, I think so. At least, like I generally don't prefer classes on weekdays. So, what should I do actually? Should we cancel the class altogether, or like should we compensate it some other time? I will do whatever you guys suggest.
The Thursday, 6 to 7.
Once again,
Thursday, 5th January, 6 to 7, if possible.
6 to 7, which day actually?
The Thursday,
Okay, so if it is okay with others, like
yes,
can others please confirm? Like So can others please confirm, like, can we have a conversation class on January 5, Thursday, 6 to 7? So I don't know how to take a poll here. Like, let me ask in a different way. So if there is someone that who is not preferring a class on that day, like, feel free to tell. I mean, I'll just do whatever is okay with the majority. And of course, like, if there is someone who is beating me on that day's class, like, so shall we fix it? Like, I need to send a mail to NPTEL people to finalize this. Like, it's not, I cannot do it myself. I need to inform them before, like, when is the next class. So is that okay? So can we finalize? Can we have a class on January 5, Thursday, 6 to 7? Is everyone fine with that? Okay. Okay, right. So thank you very much. So we'll have class.
Uh, Sir, can you explain third question?
I listen. I listen. I listen. So yeah. So the next class, the next time we'll be meeting will be on January 4th, Wednesday. Like, next Wednesday we won't be having any class, but the Wednesday after that we will be having the usual class 7 to 8. But in addition to that, we will be having class on Thursday 6 to 7 hours. That is what currently there. Is that okay?
Yes, sir.
Okay. I heard two voices. Like, it's not clear. I mean, is everything fine?
Yes, sir.
Okay.
Sir, regarding recorded videos, where shall we have recorded?
Recorded videos. Actually, I am not very sure. I am recording these videos, but I don't know how they are deciding to make it public. So we are uploading, and the NPTEL people, I think they will decide how to do with that.
Other people uploaded in the YouTube channel, sir. We shall like
Yeah,
that.
I will check and let you know. So some of them I know, but I think some of them they are not uploading. So that is also there. So if everybody else is uploading, then I'll also upload. But yeah, right now I think, like, yeah, few of my friends are also having class, so they're also not uploading. So we are deciding on what to do. So by the way, if there is any doubt in any of the topic that I cover in the class, please mail me on my ID, and I'll be happy to help. Um, so next class will be on January 4, Wednesday, 7 to 8, usual class, usual time, and additional class will be on January 5, Thursday, 6 to 7. That is what we have decided. So is everything okay? Like, so fine. So this is what we decide. So is everyone fine with this? Can I get
Yes.
one more confirmation, please?
Yes, sir.
Yes.
Okay, thanks. Thank you. And yeah, one doubt was, which question was it?
The
Third.
third question.
Okay, okay. Okay, sure. Yeah. What's the doubt?
Sir, for whole question.
Fourth we didn't do, right? Okay, we can do. Oh, we didn't do. Maybe we can do this in the one of next questions. I think it's after 8, right? So anyway, I will do this in the next class. Next class means, like, next time we'll be discussing this. So this we can do on January 5. Next class will be on, yeah, I mean, now what I'm thinking is, like, mostly we'll be doing more questions. So I think many of the people have already left. So this maybe we can so shall we do it in the next regular class? I think some of them have left actually. Is that okay? Okay. So is that fine with everyone? Like, I think some of the people have left the class, so I think it's not fair to do together. So this I'll definitely do in the next class. I mean, whatever be the topic I'll be discussing, this one question I can do in that class. Is that okay?
Yes, sir.
Okay. Okay. So to conclude, like next time we'll be meeting will be on January 4 Wednesday, and January 5 also we'll be having the addition class on 6 to 7. So okay, right? So next class will be on miscellaneous topics in signals and systems, and plus discussed in also. So any clarifications or anything? Shall we conclude the class?
So third question.
Yeah, third. Yeah, please ask. Yeah.
So whole question.
Okay, sure. So, so for others, like I think if somebody want to leave, we can leave. I think this is just to check again. So yeah, the question is like this. So what they mention is that we have a set of equations of the form A is equal to B, where this A is a 2 cross 4 matrix and B is not 0. Now they're asking like, is it possible to get a solution, get a unique solution by multiplying both left and right sides of equation by A transpose and then invert in the matrix A transpose A. So what they're saying is that we have Ax equal to B. I will multiply both left and right of this equation by A transpose. So what I mean is I will be doing A transpose Ax equal to A transpose B. I think yeah, I missed this A transpose somewhere. Yeah, this should be there. That's what. Thanks for asking. I mean, this was typo there actually, but yeah, solution won't change. That is still fine. So we multiply both left and right of this equation by A transpose like this. So this is up to here. It's clear now.
Yes, sir.
So what they're asking is that can I write like this, like solution to be A transpose A inverse times A transpose B? Can I do this? That's a question. Like, can I get a unique solution by doing this? Is that okay?
Okay, sir.
Yeah. So now the main thing here is that we need to see if we can find this inverse. Does this matrix A transpose A invertible? That is the main thing. So now from the theory, what we know is that rank of A is same as rank of A transpose A. That we know. And rank of this A is maximum 2. This is fine, right?
Yes,
Because
sir.
this is a 2 cross 4 matrix, so maximum rank is 2. So this A transpose A, that will also be having rank of 2 only. Fine, right?
Yes, sir.
So this A transpose A is a 4 cross 4 matrix, but the rank is 2. That means that is singular. Correct, no?
Yes, sir. Fine.
And it is therefore not invertible. Fine, right?
Yes, sir.
So what it means is that this A transpose A inverse, we cannot compute that. So we cannot find a unique solution by doing this. So that is the answer. Is that okay?
Okay, sir. Now I got it.
Okay. Okay. Yeah. So any other doubt?
No, sir. Thank you, sir.
Okay. Okay then. Thank you. Thanks for attending. Thank you very much. We'll meet on January 4. Advance Happy New Year. Thank you.
Happy New Year, sir.
Thank you.